Hello, and in this video we're going to look at a specific type of sequence, an arithmetic sequence, and I'm going to give you three examples of this type of sequence. The first example is 3, 7, 11, 15, 19. Second example is 5, 11, 17, 23, 29, and the third example is 27, 22, 17, 12, 7. All of these are called arithmetic sequences because they have a common difference. So in this one, the common difference is 4. Every time we go from term to term, we have a common difference of 4. So if we have a common difference, between terms, then we're going to say that the sequence is arithmetic. So arithmetic sequences have a common difference. This one looks like its common difference is 6. As we go up by 6 each time. The common difference here is -5. So all of these are arithmetic because they have a common difference. Now, if we don't have it written out in a sequence form, but in a sequence formula, we want to be able to check to see if it's arithmetic also. So what we would do here is just check the terms and see if there's a common difference from them if we check the first 4 terms. So if I put 1 in here, I would get 5 times 1, which is 5, minus 4, which is 1 for our first term. If I put 2 in here, 2 times 5 is 10, 10 minus 4 is 6. If I put 3 in there, I get 15, 15 minus 4 is 11. 4 would be 20 minus 4, 20 minus 4 is 16. So if we start looking at these terms, they're going to have a common difference of 5 each time. So their common difference is 5. And so yes, this is arithmetic. Okay, because it has a common difference. Now we're going to try to define our sequence in terms of the common difference using D as our common difference and A1 as our first term. So we're going to try to define a sequence that way so that we can come up with a generalized formula for this. So we're going to start off with A1. A2 is going to be A1 plus the difference. A3 is going to be A2 plus the difference. It's just adding the difference each time. A4 is going to be A3 plus the difference. And then we're going to want to go down to A sub n and see what that one is. Alright, let's see if we can generalize the formula here. So this one looks okay. Now on this one I'm going to use a substitution to rewrite this. I'm going to take this term A2, which I have here, and I know that that's A1 plus D, and I'm going to put that into A2 here. So I'm going to have A1 plus D, or A1 plus 2D. Okay, so this is A1 plus D. Alright, this one here I'm going to use the substitution method again. I know what A3 is. This is A3 right here, so I'm going to plug it in there. So I'm going to get, actually, we can use this one, sorry. Let's use this one as A3. So we're going to plug this one in, that's what A3 is. So we're going to use A1 plus 2D plus D. So we're going to get A1 plus 3D as our answer here. And then we're going to plug this into the next one and so on and so forth. But if we see this, we see a pattern here. All of these are going to have A1 in them, so it's going to be A1. And then our difference here is going to be related to the K term of this. If you look at this, term 4 has 3 differences. Term 3 has 2 differences. Term 2 has 1 difference. So we're going to be 1 less than the differences of n here. 1 less. So this is going to be my formula that I'm going to use for each term in a sequence that's arithmetic. Each term in the sequence that's arithmetic, I'm going to use this formula based upon the first term and the difference in which term we want. Alright, now let's use this to help us find an explicit formula. I'm going to use this formula right here to help us find this. Now these are the 2 examples that I had above. This one, remember the common difference was 4 each time. 4 for the common difference. So that means D equals 4. Now A1 here is going to be 3. It's the first term in the sequence. It's this term right here. It's the first term. So now we have a formula for this. So we can write A sub n equals A sub 1, which is 3, plus n minus 1 times the common difference, 4. So we can do some algebra to this and multiply this out. So we have 4n minus 4, and then we combine these together. We get 4n for not combining this, but we're combining a 3 and negative 4. We have 4n minus 1. So this is our general explicit formula. That means if we knew we wanted the 5th term, we would put 5 in there. If we knew we wanted the 6th term, we would put 6 in there. Okay? We would generate that from this formula up here. Alright, let's try this on the second example. This one we had a common difference of negative 5. Each time we went down by 5. Our first term is 27. So our A sub n is going to be A sub 1, which is 27, plus n minus 1 times our difference. In this case, negative 5. Alright, we just simplify this again. Okay, this is going to be negative 5n plus 5. So A sub n is, we combine these two together. We write this first, so we got negative 5n plus 32. Okay, and this is my formula. And I can test it out. If I put in 1, 2, 3, 4, 5, I should get 7. So if I put in 5 here, that's going to be negative 25. Negative 25 from 32 is 7. So it does check to give us that term. Alright, and then we're going to finish up here with answering this question using this formula. So in this case, we have a 4th term of a sequence and we have a 20th term of a sequence. But we want to find the 50th term of the sequence using saying that this is arithmetic. We need to know it's arithmetic before we can do this. So we're assuming that this is arithmetic, and in the book they'll say it's arithmetic sequence. What we have here is basically we have a couple terms in the sequence. So we're going to be looking at if I put k here on my chart and I put a sub k here, then if I put my 4th term here, I'm going to get 3 as my a sub k, and if I get a few more terms, so I get down to the 20th term, I should get 35, and I want to go a little bit further down and find out what the 50th term is, and I want to know what this is. So I'm kind of filling in this chart here with what we know. So what we want to do is we want to look at how many differences happen between the 4th term and the 20th term. So we can do that by just subtracting the common differences. So from 20th term to 4th term, there's going to be 16 differences. Or 16D, if you want to consider it as 16 differences. So that's going to happen from a sequence from 3 to 35. Okay, so that means 16 differences happen from 3 to 35. So what we want to do there is, let's erase this, 16 differences. What we're going to do here is take our difference here, so from 35 to 3, that's going to give us 32, and then we're going to have 16 differences, and we're going to divide by that, and that means each difference equals 2. 32 divided by 16, each difference is 2. So that's going to be my d value in this formula. So I'm going to have a sub n equals a sub 1 plus n minus 1 times 2. So we found the difference now. Now we just need to figure out the first term. Well, now if we know the first term, or if we know the fourth term is 3, we can subtract the difference 3 times and get down to the first term. Okay, so the difference is 2, and we're going to subtract that 3 times. So we're going to take our term here, which is 3, and we're going to subtract 3 terms of 2. So that's going to be 3 minus 6, which is negative 3. So we're saying that a sub 1 is negative 3. So that means my formula now is negative 3 plus n minus 1 times 2. Now, if we want the 50th term, we can just put 50 in here. So our answer to this problem is going to be negative 3 plus 50 minus 1, which is 49, times 2. So negative 3 plus 49 times 2 is 95. So our answer here is 95 for the 50th term on this problem. So we can do that by figuring out the differences and how many there are, 16 differences, and figuring out how far our sequence went. So we need to find out how far the sequence went and how many differences there were, divide to figure out the common difference. Okay, and once we found the common difference, we can plug that in and figure out the first term, and then we can use that to find the 50th term. Alright, so that's arithmetic sequences. We're going to go on to arithmetic sums in the next video.